Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us begin solving this step by step. Work backward from known products. The final product is 1,1-diphenylcyclopropane, a cyclopropane ring bearing two phenyl groups on C1. The last step uses CH2I to ZnCu, Simmons-Smith reaction, which converts an alkene to a cyclopropane by adding a CH2 group across the double bond. So, H must be 1,1-diphenylethylene, pH to C is equal to CH2. Moving on to the next step. G, H plus delta dash H is equal to pH to C is equal to CH2. Dehydration of an alcohol under acid heat gives the alkene. So, G is pH to C of CH3, i.e. 1,1-diphenylethanol. But wait, Simmons-Smith on pH to C is equal to CH2 gives 1,1-diphenylcyclopropane. So, H is equal to pH to C is equal to CH2, 1,1-diphenylethylene. Then, G must be the alcohol pH to C of CH3, 2-methyl-1,1-diphenyl-1-ol, i.e. pH to C of CH3, whose acid-catalyzed dehydration gives pH to C is equal to CH2. Moving on to the next step. F dash I pH in GBr excess 2H plus dash dash G is equal to pH to C of CH3. With excess pH in GBr, two equivalents, reacting with an acid chloride R-cockle reacts with 2 pH in GBr to give a tertiary alcohol RC, pH, 2 or after workup. So, G is equal to CH3C, pH, 2 of means F is equal to CH3COCl, acetyl chloride. And for the final step, D, SOCl2-F is equal to CH3COCl. SOCl2 converts a carboxylic acid to its acid chloride. So, D is equal to CH3CO, acetic acid. A, NH2 of delta dash B, H2SO4 dash C, H3O plus dash dash D plus E. D is equal to CH3CO, acetic acid. Also, E, CHCl3KOH, delta dash CH3, NC, methyl isocyanide. CHCl3KOH with a primary amine gives isocyanide, carbylamine reaction. So, E is equal to CH3NH2, methylamine. This means C undergoes hydrolysis, H3O plus, to give acetic acid, D, and methylamine, E. C is therefore in methylacetamide, CH3CONH3. The Beckmann rearrangement of an oxime using H2SO4 gives an amide. So, B is an oxime and C is equal to CH3CONH3 comes from Beckmann rearrangement of B. The oxime, B, that rearranges to CH3CONH3 must be the oxime of methyl ethyl ketone. No Beckmann rearrangement of CH3, C, is equal to no CH3 acetone oxime gives CH3-CoNH CH3 in methylacetamide because the group anti-2 of migrates. Acetone oxime rearranges to N-methylacetamide. So, B is equal to acetone oxime, meaning A is equal to acetone, CH3COH3. Molecular weight of acetone, CH3COH3, is equal to 12 plus 3 plus 1 plus 3 plus 12 plus 16 plus 12 plus 3 plus 1 plus 3 is equal to 58 g-mol. CH3COH3, C3H6O is equal to 3, 12, plus 6, 1, plus 16 is equal to 36 plus 6 plus 16 is equal to 58. 120, 60, 182 do not correspond to acetone. Megawatt is equal to 58 matches option A. Therefore, the correct answer is A. Therefore, the correct answer is option A.